Good afternoon, everyone. Today we will start the antiderivative 4.9 and chapter 5. We will solve these problems, but before that, let's explain the antiderivatives and Riemann sum. You remember this from section 4.2, right? That if f prime of x equals 0 for all x in an open interval, then f is constant. Corollary of this is this one, that if f prime of x equals g prime of x for all x in an open interval, then f minus g is constant. Then f minus g is constant on the open interval. That is, f of x equals g of x plus c. These two from section 4.2 from the mean value theorem are the reason why we add c for the antiderivative. Here is the definition of an antiderivative. A function capital F is called an antiderivative of small f on an interval I if f prime of x equals f of x for all x in I. Good? For example, if you have f of x equals x squared, what is the function that when you differentiate you get x squared? X cubed over 3, right? Or x cubed over 3 plus 5, for example, because you know the derivative of constant is 0. Are you good with this? So in general, if f is an antiderivative of small f on an interval I, then the most general antiderivative of f on I is f of x plus c, where c is an arbitrary constant. Good? Now, see this. You have sine x, 1 over x, x to n is not minus 1. What do you think? What's the antiderivative of sine x?
Negative cosine x.
Yes, thank you. So, for sine, it's negative sine x. Negative cosine, sorry. So, negative cosine x. Why is it negative cosine x? Because derivative of cosine is minus sine x, and so you need to multiply by minus 1 to get the positive sign. Now, do you know what's the derivative of 1 over x? It's ln absolute value of x. If you want, you can add c, constant, to make the most general antiderivative, plus c. Now, for x to n is not minus 1. What do you think? I will give you examples to see the general formula for x to n. For example, if I tell you x, what's the antiderivative of x? We need it to have x squared, right? So x squared, what's the derivative of x squared? 2x, right? But I want x, so I divide by 2. Good? So x squared over 2. What about x squared? Same idea, I want x cubed. When you differentiate, you get the 3x squared, so you need to divide by 3. What's the general formula? What do you think? Do you see?
X to the power n plus 1 over n plus 1.
Yes, thank you. But here, minus 1 is not included. Minus 1 is not included because the formula is not defined for minus 1, because it will be division by 0. And also, the answer for minus 1 is here, part B. Good? But now let's talk a little bit more about part B. because this will be the answer that we will use, but there is more about this, about part B. Let's get back here. I will show you more about part B. See here. So the most general derivative is ln absolute value of x plus c on any interval that doesn't contain 0, okay? In particular, this is true in each of the intervals minus infinity to 0 and 0 to infinity. Because remember, the idea of adding constant, it's for open intervals, right? But this function, ln absolute value of x and 1 over x, they are defined for everything other than 0, right? So they are defined for these two intervals, minus infinity to 0 and 0 to infinity. But these are two intervals, two open intervals. So for x greater than 0, which is 0 to infinity, we have constant c1. For x less than 0, we have another constant c2. Okay? So this is the most general antiderivative of 1 over x. But we will consider it a one constant, okay? So we will have this answer, ln absolute value of x plus c. So this is just for understanding that this is the one that is really the most general. Good? Now let's see more. So if you have function constant c times f of x, then the particular antiderivative is c capital F of x. So the multiplication by constant will not affect the antiderivative, okay? Similar to differentiation and limits. When you add f of x plus g of x, then the antiderivative is the antiderivative of f plus the antiderivative of g. Again, if you have x to n is not minus 1, you have this x to n plus 1 over n plus 1. 1 over x, ln absolute value of x. E to x is e to x. You like e to x, right? Now b to x is b to x over ln b. So the difference here between...
Professor, by mistake, I left. Did you take attendance? I left for a minute.
Did you write your name?
لا والله not yet. هلا right my name.
Okay. Write your names, student ID, and your name, okay? Now here e to x, the antiderivative is e to x. B to x is b to x over ln b. Note here that the difference between differentiation and antiderivative here, that for derivative you multiply by ln b, right? But for antiderivative you divide. Good? Now the antiderivative of cosine is positive sign. Next we have the sine x, antiderivative of sine x minus cosine x. Secant squared x is tan x. Secant x tan x, secant x. 1 over square root of 1 minus x squared, you have sine inverse x. Or cosine inverse x. I mean minus cosine inverse x. Positive sine inverse x or minus cosine inverse x. Anyway, let's get back here. 1 over 1 plus x squared, tan inverse x. You didn't study hyperbolic trigonometric, I mean hyperbolic functions, right? This is hyperbolic cosine, hyperbolic sine. I think these are not with you, right? But if you are curious, here is the definition. Cos x is e to x plus e to minus x over 2. Sin x, e to x minus e to minus x over 2. And you have this identity. So they are similar to sine and cosine. They have their own identity. Cos squared minus sin squared equals 1. But if this is not with you, forget about it. Let's solve the problems from here now. She sent me these problems, so let's solve them. Who wants to help me solving this one? Find the most general antiderivative of the function. Check your answer by differentiation. Use C for the constant of the antiderivative. Who wants to help me? Do you hear me? So we have f of t equals, first we simplify. Okay? We get 2t over square root of t minus 4 over square root of t. You distribute the division. So plus 2 square root of t over square root of t over square root of t. Then you simplify, you get 2t over square root of t, 2 square root of t. But the square root of t is t to half, right? So let's write it t to half. Minus 4, 1 over square root of t is 2 to minus half. Then the last one plus 2. So what's the antiderivative here? What do you think? Do you want to help solving this?
Professor, can you see my name? Because I don't know if you can see it.
Did you write your name here?
Yeah, but I don't know why I can't see it. حمزة أيوة هون حمزة يفاوي بلا هاي.
Yeah. Now let's solve this one now. We will use the rule t. What's the antiderivative of t to n? N is not minus 1. T to n plus 1 over n plus 1, right? So here we have f of t equals equals 2 times t to half plus 1, right? Over half plus 1 minus 4t minus half plus 1 over minus half plus 1, right? Plus 2t. Now it equals 1 plus half 3 over 2, right? So you have 2t 3 over 2, then you divide by 3 over 2, right? So you multiply by the reciprocal of this. So it's 2 times 2 over 3. So we have 2 over 3 here, and here 3 over 2. Now minus 4t power half. Now you multiply by 2 over 1, okay? So here, multiply here, for example, times 2. Then plus 2t. Then simplify, you have 4 over 3 t to 3 over 2 minus 8 t power half plus 2t. Are you good with this? Do you have questions? Now let's solve this one. Find the most general antiderivative of the function. Same idea. Check your answer by differentiation. Use C for the constant of the antiderivative. Remember to use absolute values where appropriate. So here f of x equals this. What's the first step?
Split it.
We need to simplify, right?
Yes.
X to 5 divided by x to 4, x. Minus x cubed divided by x to 4 minus 1 over x. The last one, 8x over x to 4, it will be 8 over x cubed. But this you can write it 8x to minus 3. So what's the antiderivative of this? X, you get x squared over 2, right? Minus 1 over x minus ln absolute value of x. Last one, you have 8x to minus 2 and you divide by minus 2. 8 divided by minus 2, minus 4, right? So minus 4x to minus 2. Check now by differentiation if you want. F prime of x equals 2x over 2 x. Then absolute value of x is 1 over x, so minus 1 over x. Last one, minus 2 times minus 4, x to minus 3, which is 8x to minus 3. So it's correct, right? Let's now solve this one. If you have f double prime equals 2x plus 6e to x. Okay? How to solve this? So here, use c for the constant of the first antiderivative and d for the constant of the second antiderivative. So we will use antiderivatives to get back to f. So first, let's start. We have f prime of x. So the antiderivative of f double prime is f prime, right? You have 2x. What's the antiderivative of 2x? 2x squared over 2. So it's x squared. Then plus 6e to x plus c, because for the first antiderivative it's c. Then f of x equals x cubed over 3 plus 6e to x. How to integrate constant? What do you think? The antiderivative of constant is x, right? C times x. So cx. Then plus you add d. Good? Do you have questions about this? You need to participate, okay?
Okay.
Now let's solve this one. What do you think? How to solve this?
We distribute the secant first.
Yes. So we have integral. You can take 2 out if you want. Secant t. It's secant t times secant t, right? So secant squared.
Yes.
dt plus integral. You can take 3 out. Tan t dt. What's the answer of the first one?
Tan.
Yes. So 2 tan t. Then plus. Do you know the other one?
Professor, I think we needed to distribute the secant on both the secant and the tan. So you get 3 secant tan.
Oh, we have parentheses here.
Yes.
Yeah, sorry, I didn't. So we have integral 2 secant squared t plus 3 secant t tan t dt. Okay. Now we distribute. We have 2 secant squared t dt plus 3 integral secant t tan t dt. We get 2 tan t. Then the other one, secant t, right?
Secant. Yes.
Let's see. If we have integral tan t, do you know how to solve this? I think this will be for later, right? For when we take integration by substitution. So forget about this now. We'll solve it later. Now we have this one. But before solving this one, let's see the Riemann sum. Let's get back here. So here, the meaning of integration is area, okay? Area between the curve and the x-axis. But before that, assume you want to find the area between the curve and the x-axis. Do you have formula for this? I mean the area, this area here. Do you have formula for it? No, right? So what can you do? You can draw rectangles like this, and then you add the areas of these rectangles. You get approximation, right? Good.
Yes.
Here we are using left endpoints. Left endpoints means what happened here? I will show you now. Why is it left endpoints? Because see here, we divide it, just 1 second, we divide it like this, right? But see here, the height of the first rectangle is 0, right? So we are taking the left point. Then the second one is this one, left endpoint. This one, left endpoint. So you draw the rectangle from the left endpoint. See here, left endpoint. Good. See the other one, right endpoint. Right, right. So you see here that for this function, the right endpoints gives you more than the area, right? Using left points, you get less than the exact result. Now, here you have the exact result. For the right endpoints, you have the 0.39 like this, and for the left endpoints, you have 0.273 like this. The area is between them. If we want better approximation, what should we do? What do you think?
We can make more subdivisions or turn the areas into trapezoids, I think.
Yes. Using trapezoids is one of the methods to approximate integrals. It's called trapezoidal method because sometimes you cannot solve every integral, so sometimes you use approximation techniques. Now, more general, you have this formula. So the area A of the region S that lies under the graph of the continuous function f is the limit of the sum of the areas of approximating rectangles. So here we have A equals limit Rn as n goes to infinity. So when the number of rectangles go to infinity, okay, when it goes to infinity, you get exact result of the area. See here, remember, what's the area of each rectangle? Since they are equal subdivisions, the width of each rectangle is delta x, right? What's the height? The height is the image, right? The image of the x value, right? This is the height of the function. So how to get the area of each rectangle? You multiply delta x times the image of the function, right? So you get this formula. Delta x times fx1 plus delta x times fx2. Good? You also have this one for the left endpoints. You have for left endpoints you start from x0, because remember I told you for left endpoints you start from the left, not from the right. Are you good with this? More generally, you can take any sample points. I mean, here you have right, here you have left, but you can take between right and left if you want. So here's it's more general. You can also take midpoints if you want. So see here, you call this lower sums. Lower sums because it's less than the exact result of the area. This one here, upper sums, because it's more than the exact area. Okay? See this example here. Estimate the area under the graph of f of x equals 1 over x from x equals 1 to x equals 2 using 4 approximating rectangles and right endpoints. Sketch the graph and the rectangles. Is your estimate an underestimate or an overestimate? So we want it between x equals 1 and 2, right? We are using right endpoints. So if you are using right endpoints, first you calculate what? You calculate delta x, right? Delta x is, we are using how many rectangles? 4, right? So we have delta x equals, here this a, here this is called a, this is called b, okay? Delta x equals what? b minus a over number of rectangles. We have 4, right? So over 4. Then 2 minus 1 over 4 equals 1 over 4. Then x equals 1 is called x0, okay? If you are using right endpoints, for right endpoints you start from x1, okay? x1 equals what? In general, let me show you in general. You have xn equals xn minus 1 plus delta x, okay? So here, x1 equals what? Equals x0 plus delta x. What is x0? 1, right? Delta x is 1 over 4. So 1 plus 1 over 4, you get 1.25. Then, how to find x2? x2 equals x1 plus delta x. So you have 1.25 plus 0.25 equals 1.5. Then x3, same idea, 1.75. x4, 2, right? So R4 equals what? Equals 0.25, which is delta x. So delta x times fx1 plus fx2. You can take delta x as common factor, I mean. fx2 plus fx3 plus fx4. Good? You calculate these values using your calculator. You will get this answer, 0.63. If you want to see the graph, it's here. Here you have 4 rectangles with right endpoints. If you solve it with left endpoints, this time you start with x0, 1, and you stop at 1.75. Here you get 0.75. So here this is overestimate, right? Where is the exact value here? Yes, the exact value is here. The exact value is ln 2, which is 0.693. So we are getting good approximations, right? With 4 rectangles. We have here 0.63. Here we have 0.75. If you add more rectangles, you get better answer. Here you have another example. F of x equals sine x from x equals 0 to x equals pi over 2, using 4 approximating rectangles and right endpoints. If you calculate the exact value, you will get 1. Okay? But now let's use approximating rectangles. So here we are using right rectangles. Here left rectangles. When you use right, you get 1.183. Using left endpoints, you get 0.79. I think for this example, the right endpoint is better, right? You also have this one. Using 4 rectangles for 1 plus x squared, right endpoint, you get this one. You get 7.4. But the exact result is 6. If you use left endpoints, you get 5.1. Yes, it's right. Here right endpoints, here left endpoints. Down we have what? Same idea. We have right, but now how many rectangles? 6 now. We added more rectangles. So when you add more rectangles, you get better answer. Remember, the exact answer is 6. So now it's better, right? 6.8. Here, using left endpoints, 6 rectangles, you get 5.3. If you do midpoints, see here, this is 6 rectangles. No, it's 4, sorry, it's 4. So 4 rectangles midpoints, you get 5.85. The midpoint is very good, right? Because the exact result is 6. So if you use 6 rectangles for right endpoints, you get 5.9. But with just 4 rectangles, using midpoint, you get 5.85. So midpoint is very good, right? Do you have questions? Are you good with this? Do you hear me?
Yes, Professor, we can hear you.
See here, you have this, you can use Dismus. You have Riemann sums calculator on Dismus. If you want, you can choose any function. Let's now solve the exercise, this question here. Consider function f of x equals 25 minus x squared on the interval minus 3 to 5. So use a Riemann sum to estimate the area under the graph of f between minus 3 and 5 using 4 subintervals and taking the sample points to be left endpoints. So left endpoints for rectangles from minus 3 to 5. The function 25 minus x squared. 25 minus x squared. We want it from 3 to 5. Minus 3, I mean. Minus 3. Minus 3 to 5. Right? Yes, minus 3 to 5. We want 4 rectangles. Here n is the number of rectangles. Choose it to be 4. So 25 minus x squared, right? Yes, it's right. Minus 3 to 5, then number of rectangles 4. Left endpoints for the first one, right? Yes, left endpoints. For left endpoints, you use 0, okay? Here, 0 for left hand, 1 for right hand, 0.5 for midpoint. It's already left endpoint. You get 160, okay? Are you good with this?
Yes, Professor.
Okay. Here is in the middle, these are two rectangles, but they seem to be one. Because see, here it's clear that you have one, but here it's because they have the same height. See here, here is the left end point. I will show you. So here you have, I will use red. So here you have the first left end point, then this one, then this one, then this one. Okay? So these here in the middle, they are two rectangles, but they seem one. They seem to be one because they have the same height. Good? Now, part B, right endpoints. Right endpoints, you make it one. See here. Now let's explain this one. So here we are using right endpoints. So you start here. This is the first point. Because remember, when you do right endpoints, you start from here. Left endpoint, you start here. So it's right, you start here. Then this one, then this one, then this one. It's 0, so you don't have here because it's 0, right? So here it's lower, I think it's lower sum, right? Yes, it's lower sum because see here, we don't have this here, we don't have this here, and this here, where is the answer? Ah, yes, it's here, 128. The left end point was 160, right? Now the next part, use midpoints. Let's use midpoints. Now you put it 0.5. I mean midpoint, you get 152. What do you think? Is it good? If you want to get the exact result, we solve the integral, right? So we have 25 minus x squared. We will solve the integral from minus 3 to 5. Yes, minus 3 to 5. Of 25 minus x squared. You get 25x minus x cubed over 3 from minus 3 to 5. Then you substitute 5 and you substitute 5, you get 125 times 5, 125 minus 125 over 3. Then minus, now you substitute minus 3. You get minus 75 plus 27 over 3. Plus because minus 3 cubed minus 27. And you have minus, it becomes a plus. 27 over 3 is 9. Minus 25 plus 9 minus 66. So we have 125. Let's make common denominator. You have 375 minus 125 over 3. Then here you have 75 minus 9, 66. So minus 66. Which is minus 198 over 3. You get now mm, is there a mistake here? It's a plus, not minus. Now it's correct. Then the exact result 448 over 3. You got what is the 448 over 3 equals? So this is the exact result, okay? Are you good with this? This method we will study it in the next section, I think, the fundamental theorem. But here, part D tells you use the theorem above to find the exact value of the area. You can use left sum or right sum to find the exact value. So we solve the limit. Okay. So for part D, which sum do you want to use? Left sum or right sum to find the exact result? What do you want? Left or right? Left or right?
Have a good day, Professor.
Yeah, thank you.
Professor, we leave?
Yes, leave.
Yes.
Okay, bye.